Continue to outward pressure in this kind of star has to be enough to gravitation. If the gravitation is enough, it will be very short period of time to just simple to crash to each other. It will be implode, and all the gravitational mass would be immediately creating such a huge singularity, some kind of very dark and thick dense of the nucleus, what is most called black holes. And the rest of the remaining mass might be explode to the K-moon as a hypernova. But this is what I expected in the future, this kind of star. Pretty much any kind of star with enough star mass, it could be to end for a very, it's expected to be over 10 solar masses. 10 solar masses and the stars have enough gravitation to enable this process of the going a supernova. And the kind of stars like we have 100 times masses are expected to be hypernova. Hypernovas are extremely rare compared in this kind of unit. Talking about the census of the 10 million years in them happening once in the total occasion. If there is expected, they are very short period of time. Alright, the only universe there was a lot. And let me start with the other universe. There was a lot of the very big stars. They were very, very unrich in metallicity. Metallicity. They call metal every other except hydrogens. The early stars all well about hydrogen, and there was almost no other elements in the universe. And then the hydrogen was dominating factor in the very early part of the universe occasion. Therefore, the first generation star all what come of the hydrogens made of the deuterium and protium. Right, and now we should the helium picking more and more all time to the more radiation. We know about the kind of elements like iron 57 is occasion dominant factor in the universe. There is couple of nickel 58 and derivation and iron 58. 7 are the two most stable isotypes of the any elements in existence. More than hydrogen, helium, any type of occasion. This is expected in the universe if the occasion are keeping on some kind of exchange. What change occasion shall talk about occasion? If the every and the material of it in itself turning. The one reason what iron 57 it has the smallest amount of the current physical characteristics. Call it you know about this occasion electric binding have a lowest binding energy. Because you have a lower binding energy, it is most likelihood that the occasion you need the lowest amount of energy to holding yourself. So this is the reason why the iron 57 is so stable. Alright, in the universe there is kind of theories about the proton and neutron decays. Yeah, this kind of decays will be evading this. We talk about long scales of the time. Alright, this now is expected to be 13.5 billion total years old. This kind of the existential is expected occasion to this kind of time scale. When the stars will be stopped right. There is less and less stars ever made, you know. There is no less kind of the clusters because the space is a distance big and always increase. Early universe was very small distance. Remember in an example the same volume. The volume, what is the modern time? There was like modern time, except take it, there was thousands times more dense of the material, matter and gravitation there is now. So even seems that the gravitation is such a powerful force against dark energy. The gravitation itself doesn't dominate completely thanks to the dark force. Anyway, you will think about the whole universe. If there would be dark force, the universe would be every mass of the entire universe. Gravitation would be a vibration. Nothing will exist apart from that singularity. So there has to be this kind of force. This is ensuring. We talk about anthropic principle that I don't know what anthropic principle means. Well, let me tell you, I don't. And myself, the anthropic principle is something which I myself not exactly able to tell. But I think about that the humans, except that are able to be alive, the perception of it, it means that there have requirements that the universe couldn't be otherwise. It is a necessity that the physical laws and all the vast of the whole chaos of the universe must have a certain kind of a therefore gravitation is not only a simple force which dominates whole existence. There is other forces, and thank you to those other forces the reality is how it is. And the question is here the future. What has the future occasion? It's like about the universe which is have a flat curvature. If there is different kind of curvature, the calculation negative, positive, minus curvature. Alright, in a flat universe, it will be continuous. This kind of math will be continuing. What the expansion, enormous. What is it in conclusion? In existential given in no time except for one quick Googleplex year, except for just Google years, except for 100 or times 10 and 100 exponent. So in this MOD era, what we expect, there is no single star anymore having enough energy. There's no single red stars or the last of the cases. Those stars which will remain, they call it the remnants, the brown stars. They call the red stars. The browns are the actual elevation. When they call the blacks dwarfs. The black dwarfs are stars which have no any more energy in terms of they are not holes, but they are holes are just to call it such an extremely dense object. We have so that they are able to every particle physics itself, so they don't any indication information anymore. Instead of example to black, so they are combat objects which are able enough space to them around themselves. Occasion the curvature. Thinking about the something things called photon sphere, very unusual things. You need enough gravitation to create. You can create this kind of photon sphere in this kind of anywhere in the universe, except in the around side of the curtain combat option, neutron stars. What if the photon sphere means? Except if you release a photon, except a light bulb, it will be possible to just around this object is spreading. So interesting, you're able to get the information to other side of the stars. It's simple watching, if you want, guys, all around it, even you don't see it, because the photons never actually leave this occasion. They will be just going to have an orbit around this combat object. Let's speculate here, actually. This is example a classical black hole here. It is a dense object. It has a score which is exceptional. It's like a quantum. All the materials are circuit. I mean, this kind of gravitation is enormous in this, but at the most occasion, it's not gravitation what actually dominate this kind of the planet. It is the different forces inside. When I remember occasion, we will have in one atom here, another here. Alright, you can have protons. When occasion, this kind of star, the protons are even destroyed yet. They will become in quantum quarks. And in quark stars, occasion, only quarks exist. When these quarks even occasion split, so they come in energy occasion. The successive generation. So they get the filaments which is created related to elements, and this kind of stars, they are no the material inside the black holes. It is a question of what remains. But the fact is that they are the best kind of showing of what kind of materials are made the atoms, because no protons, electrons can survive that. They will become ionization filaments of the quarks, the quantum filaments. And so you get the stars, black holes are made of the quantum filaments, which is the star uniter. Alright, there is huge distance occasion, we will be pretty much a vacuum here. It's not a vacuum example duration around the star. Will be always obvious circuit in this case a central filament calculation. This is a black hole. There is a collocation of it. The distance r reduced partial ready with is of course there is M horizon. Then inside this partial horizon is a long distance of pretty much, it's not completely vacuum or nothing, but there is here a kind of a quantum sphere here around different object. And even in this case, the physics inside of the black holes are completely different composition, and this is how the black holes are interesting, or what occasion, because they are black combat objects. Most of occasion enormous small is their location in space, because this kind of black hole itself is very small indeed. Ratio. Example here, this one we have 100 solar masses. It have therefore the Schwarzschild radii 100 solar masses, something like 40 kilometers. Okay, 40 kilometers here, this occasion. It will be having only something like a 200 meter, exceptionally huge, dense object. We have all the mass, 100 solar masses in 200 meters. But it will be have still this kind of quantum field around it, for the remaining the 40 kilometers around it, with this imminent horizon, with information cannot leave this sphere because the gravitation will be pulled in this quantum field. And this is interesting about the observing the black holes. Even you can never get the information, you can still already know about those things.